Today's topic is Knoevanagel condensation reaction and from the unit 4 aldehydes and ketones after the Perkin condensation reaction. Knoevanagel condensation. In the Knoevanagel condensation, the Knoevanagel condensation reaction is the organic reaction named after Emil Knoevanagel. That is the name of the scientist. It is the modification of an aldol condensation. The Knoevanagel condensation is a nucleophilic addition of an active hydrogen compound. I have said you earlier that what is the active hydrogen compound. If you are taking the malonic ester, that is COOET and then CH2COOET. In that, if you will remove one of the hydrogen atom, at that time what happens, that whatever the electron withdrawing group is there, which is attached to the methylene group, because of that electron withdrawing group, the hydrogen of that methylene group will become more acidic and that will act as an active hydrogen compound to a active hydrogen compound. Okay, so in this reaction the active hydrogen compound to an that nucleophilic addition is taking place between the active hydrogen compound between the active hydrogen compound and an carbonyl group. It can be either an aldehyde or the ketone followed by the dehydration reaction. I have said you that condensation reaction is nothing but it is a dehydration reaction, which is the removal of water molecule, elimination of the water molecule which takes place. That is your dehydration reaction or the condensation reaction. And here the product which is obtained over here is, it is the alpha beta unsaturated compounds. Either it can be a ketone or an aldehyde, and here it is often the product is in the Knoevanagel condensation, it is the alpha beta unsaturated ketone which is a conjugated enol. So it is a type, this reaction is a type of a coupling reaction. Coupling reaction is basically the two compounds. If you are taking two compounds and if you are joining the fragments or one fragment from one of the compound and the another in the presence of the metal catalyst, that gives that results you in the coupling reaction. It is also important reaction which is present in the organometallic compounds. Okay, organometallic compounds in which the R and metal complex. R is nothing but it is the organic fragment attached to the main group center, which is the main group center, which is the metal ion, on which reacts with an organic halides of the type Rx, R-X with the formation of a new carbon-carbon bond in the product such as R and R-. So moving on next slide, the reaction in that we have studied in the introduction which type of the reaction it is, what that reaction says, what will happen. Okay, so in the reaction, what the reaction is taking place, how the reaction is taking place. Here what we are going to do is, in the reaction, the carbonyl group, you know that the carbonyl group, it can be an aldehyde or the ketone. We are taking that and we are treating it with the base catalyst. Here we are using basic amine. Okay, and the active hydrogen component has the form of ZCH2 and Z. That is your Z will be the electron withdrawing groups, which is like diethyl malonate, Melgem's acid, ethyl acetoacetate, EAA, or malonic acids or cyanoacetic acids, etc. and so on. For instance, if you are taking the ZCH, R1 and R2, here we are using the nitromethane, and so nitro group will be your Z group, and then CH, R1 and R2 will be your methane group. That will be your hydrogen groups attached to it. And okay, so where Z is an electron withdrawing group, I said, and then in the reaction, if you will see here, you are taking a ketone and then you are treating it with the base in presence of an electron withdrawing functional group, and then electron withdrawing functional group attached with the methylene group, that is your active methylene hydrogen groups. Okay, resulting in the alpha beta unsaturated ketones. Moving on to mechanism, here before going to mechanism, Doebner is the scientist who has added some of the things with the Knoevanagel condensation. So it is known as the Knoevanagel condensation, Doebner modification. He has modified certain things over here. So the condensation of the carbon acids, if you are taking an acid, it is the carbon acids. If you are taking the esters, it will be a carbon ester compounds with the aldehydes to afford the alpha beta unsaturated compounds. So here in the Doebner modification, which is possible in the presence of either it can be a pyridine or it can be a piperidine in induced decarboxylation. Okay, if you in the first thing in the reaction, if you will see, you are taking the diethyl malonate and then you are treating it with the aldehyde in presence of piperidine. In presence of piperidine, upon reflex with the benzoyl, at that time you will get the alpha beta unsaturated esters you will get. And then further, if you will remove the two molecules of ethanol and the decarboxylation, if you will do with the liberation of the carbon dioxide, upon hydrolysis on heating, you will result in the alpha beta unsaturated acid. So it is the one way. And then the next, if you are taking the starting material as the malonic acid, okay, if you are taking the malonic acid and then again if you are treating it with an aldehyde with the different base, that is your pyridine will act as a base, upon heating you will result in the alpha beta unsaturated acid. Moving on to mechanism, here there are two steps in the mechanism. The first step is the formation of an enol intermediate. In the first step you are taking the starting material, which is your diethyl malonate, and then you are treating it with the base, which is your piperidine. Okay, so in the piperidine, if you will see the structure, at that time you are having NH and then the lone pair of electrons with the cyclohexane. Okay, it is a heterocyclic compound which will act as a base. And here in the nitrogen atom, there is a lone pair of electron which goes and abstracts the proton, and then once it will abstract the proton, the bond will shift and it will make a double bond. The double bond will shift and make a negative charge upon the oxygen atom, resulting you in the enol intermediates. So once you get that one, the pyridinium ion will get cleaved out from the reaction, and then you will result in the ions. Okay, so in that ions, what you have to do is you have to do the canonical structure form. To this stable structure only you are taking, and then you are moving on to the further step of the mechanism. So first, whatever you will get in the product, you are taking that one, and then you are doing the canonical resonating structures of that. And then if you will see here, you are having a negative charge which again comes back, and then there is a shifting of the bond making it as a charge, which will generate the carbanion. Okay, that is your enol intermediate. And once you will get the carbanion, on that carbanion again the negative charge will shift towards this side, towards your left, and then again that bond will shift and makes your negative charge upon the oxygen atom. That is your resonating structures. So here you are taking the middle one which is generating the carbanion, and then you are attacking to the nepins. In the carbanion you are taking, and then aldehyde. Now the aldehyde comes into picture. The anion, which is carbanion, will go and attack to the carbonyl carbon of the aldehyde, and when it goes and attacks at that time, the bond will shift, make a charge as the O negative, resulting you in the first structure that will generate a alkoxide ion over here. And then whatever the piperidinium ion which I have showed you in the earlier stage, that is in your step 1, which has been removed over there, that you are joining over here, and then at that time what happens, the O negative which is present over here, that will abstract the proton, and the bond which is present between the nitrogen and hydrogen, that bond will neutralize the positive charge of the nitrogen atom. Okay, and then there is again the cleavage of the piperidine, and after that you will result in the structure number 2. So in this structure number 2, again you are taking the piperidine, and then whatever the negative charge which is present over there, or the lone pair of electron, will abstract the proton, and this bond will shift and making it as a double bond, and there is a cleavage of the water molecule or the hydroxide ions over there. And then if it is cleaved out as a water molecule, it is a decarboxylation reaction which is taking place. Decarboxylation reaction and the elimination reaction. Inducing, why it is telling? Because you are inducing the piperidinium ion in the after this first structure, you are inducing the piperidinium, and then again you are eliminating the water molecule, that is a dehydration reaction which is taking place over there. At that time, that is the elimination reaction, resulting you in the alpha beta unsaturated compound. First it is an ester, and further if you will do the hydrolysis for the third structure, at that time what happens? One of the ethanol molecule will get cleaved out, and then two of the ethanol molecule will get cleaved out, and carbon dioxide decarboxylation which is taking place, resulting you in the alpha beta unsaturated acid. Thank you.